Hi everyone, today is ATM case by Jean Wolleh with Hungarian Algorithm. This case is about withdraw on money from ATM with different node, and then we want to priority the biggest nodes first and try to get the minimum bank node, but the priority is from the biggest one first. So we have two tab here. Another one is bank. So this is the header, which is I'm just gonna copy. So we have a node and limit of that node, node 2 limit of that node. Okay, and then this is just go with B table name. Okay, start with this. Level 1 is just like how many node from this one from amount. So we just go divide this one with this, and then level 2. We have to find the average from the next largest and next smallest from this value. So the next smallest from this one will be floor on this and this. And then the next largest will be this amount plus 7, which is the value. So the average will be plus this one divided by 2. So this one will go average. Okay, next. Now we have a different node, and then this is not sort it from large to small, so we have to sort that one first. Okay, that V is all this. Then Vs will be sort by V and minus V, Vs. So now we sort this. Then after use, okay, we start with this amount. Okay, I'm just gonna start this one. Oh, let's start this. Okay, go on top here. Now, the first amount we will use the node of 85 and then continue from that. So this means we want to like we have for used before, so we have to for this one with this. So this is the amount used by the node value of 85, and then the remaining will be this minus this. So we will continue like this, and wait, I have to go from this one down. Go from this, go from this. Okay. So this is like the remaining node used here, and okay, just go a bit more. And then now we want to find how much we use on each node. This means I have to go this one minus this one. So this is amount using, which is the floor of this. Okay, almost the same. But we have to continue from the previous one. Go like this. Then the last one is the remaining, which is in most of the case it will become 0, so we can use this one. So we will continue with this one. I'll go with scan. Leave the first one blank, so it will not do anything on the first item. And then lambda a v. No, I already use v. A n number, and then I want to floor a with n. Okay, just go with this. So this is the amount we use, but we have to deduct from the previous amount. This means this one we have to go a minus this. Now we got the same stuff at this one, and I will call this one as remainder. Now we want to do the first 4 minus last 4, which is we can decide how much we use for each banknote. So D will be drop by last and drop by first column. So this is the amount we use. Okay, I'm just gonna continue with this. Oh wait, and then we need to find how many node bank. So we divide this one by VS. So this is the node bank that we use, and then this will be sum of this. Now we have this. Okay, I'm just gonna ship this one. This. Now we have the limit of node here. It means we cannot use all 25. We have to limit this one at 17. So the limit will be here, and then the limit is, okay, I'm just gonna, so this floor is the amount that round down, so this is maximum, and then the amount of limit will be this number 17 multiplied by 85. So we have to find that number, but now that I already solved this one, this is not aligned with the value with unsolved, so I have to go like this. So I can go like, so if I have 85 here, I can X lookup for this one, for the unsolved, for the limit to get how many, and then this one I multiply back with the number. So this is amount used with 17 number of node here. So this means I have to determine it here with the minimum of n, which is about, then multiply by X lookup on n on v on this cross. So now this is the amount of using. Then this I can sum. For level 5, we want to go through all the bank and find which is the number of the base node that we use on this one. So this is the bank, and then level 5 we only use this. So I'm gonna name this one as BV, and then the bank name will be here, BN bank node. And with this, if I go on this, okay, go on header and drop the first two, have this one, and then if I wrap row or wrap call with this, so the first row will be the node, and then the second row will be the limit node. That means I can take the first row for the value, and then take the last one for the limit. Okay, so I'm gonna apply this here. Let's just go with this. This will be the amount, and then let's say this is the financial pivot financial group, so that B will be, just for sample, pivot this one. Okay, and then wrap row, the B will be wrap call of B by 2. Then this will be first row of W, so take W first row, and then the limit here will be drop W by first row. So this is how much we use, and then we need to sum this one up. So this is just like one bank. We need to find all the bank and then sort according to that one. So this one, instead of B, just go with by row on bank value, and then lambda B. I already have B here. The rest are all the same. Just get rid of this cross. So this is the bank, and then this one will be number. So I, okay, go with I. Then I need the bank name on top. Which means I have to go bank name and this bank name, and then I have to sort from small to large. So sort by n to get this, and then I need number 2 on this one. So this will be index. This now, this one is we will select one on the same project. We will select the bank only one time, so we cannot, and then go to find the minimum bank node for each project. So from here, now I only need the I. Okay, this is the amount I. Okay, so this is amount used for this bank, but for sample here, it's just use the first bank. So just this for sample here, this is first bank, so just go with this. So the first bank I use 24, but the remainder we will not use the sample. So this means this will be go back to bank value here, and then I have to find all this. So to row with this and to row this one. So this is the amount using for this, and then I can go down. And now we have 10 column here, which is to row all bank name. So this is each bank we use, and then from each project here we can select once. So like if we go select this, then we cannot select any pivot financial, so we have to select non-duplicate bank. And normal state here, lazy one, is to use to try all, which is brute force. So I have to bring in lambda. And okay, so let grid will be all this. Now we have 6 row. That means I have to promote 6 by 10 bank, but the rest will be 7. Now I need column number. So C will be C will be columns of no, not column, row R. Rows of GR. So this one have 6, and the rest I have to go with 7. Now I have to create permutation on this one. So P will be Percom, no, Percom, which is the function that I create to go with this. So we have 10 bank and R. Oh, this is a cool question. Thank you. So this like we have select 6 bank, and then we random through all this, and this is like how many rows here? Rows of this will be 150,000 rows. So we have to try all this and then find which one has a minimum. So to select this one, I have to go with index on grid, and I have to select each row here. So this means sequence of 10, no, sequence of R in column. So for each one, I will select each row. And then the permutation part will select the bank here, which is go into column, because like we have 1 to 10 column here. So this is number 1 to 10. And now we have to sum and then find which one has the minimum. So this part will be by row and sum. Oh, I have to go with this one and then find the minimum. So I just use XLOOKUP for 0. Return the P and then look for the next structure. This one will be X. So this is the bank we select. So for amount number 1, we select bank number 5. This means I can go with index GR, sequence of R with X. So this is amount we use. And then we also have to choose the bank and then put it in this format. This means I have to go index on this one, or I have to lock cell and then with X and this and this. Cross. And then now I just have to go with to call. So this one take quite some time to calculate. So this is first one. The second one, I have to select 7 banks in the project. 7 amount here is take some time to calculate and all this. So this is one way to do, and then there are another better way without brute force, which is called Hungarian algorithm. So I already create this lambda, so let H should be Hungarian, and then I can select all the grid within first project here. This will select the minimum value for each bank, for each amount. And now that I have this, I have to go if it's number, I want bank, which one? Bank, and put it in this format, and H. So the thing, the asterisk will show as error here value, and then with this I can go to call without error here. So I still got this, and then this will be 7. Then I can check this equal to all this. So all true here, which is good. Back to the bonus. So which is the most common one? So we have to do the mode, which is find the maximum number of number here, and then filter bank with left of bank header equal to node, which is equal to n. And then bonus 2, we will want to withdraw all amount from level 1 to 6 without sample, and then sum how many nodes you receive. Withdraw from the bank with least money reserve first and continue ascending. So we go start from how many amount first. So sum filter amount will be in this column. So just go with 0 here, and then for this one have to be number. I can go with n plus here to check if it's number. So the example will be exclude. So this is amount we need. And then go with bank here. Now we want to know the reserve money. Okay, I'll go with by row. Drop B column 2, which is not includes the first column. And then lambda x. And then I go the same. So let W be wrap call of x by 2, and then the first row will be node. So sum of take W first row and drop W first row. So this will be the reserve of the node, and then I can sort according to this ones. Okay, put it here. Sort by drop B column 2 with this. Now I sort according to that one, and then now I have to find the amount used for each one and the remainder from each amount. I can go back to this part. Okay, I'll just go with this one. Let here. So let now, but I need the bank, so which is the B here will be this one, and the rest will be the same except the amount will be on top here. So this one we use 700 dot, but we want to know the remainder from this one. It means I already calculate the remainder from here, and the remainder from this will be the last column. So it's stack by -1. Drop take. This one will be the remainder of that, and then this. Okay, so this is the remainder. This format, and then just go down here, and then the rest will be 0, and then I can sum all this to get the amount of Oh, hi Harry. When did you start learning Hungarian algorithm? What the reason for it? Just after I try Chong case here. Hi Chong. Because this take quite some time to run, and then I want to know if there any method can do that, so I study that one. Okay, just try to finish this one. Okay, now bonus 3 level 1, how many node will receive with the value of node less than 10, less or equal to 10, and then so this one will be sum of sum if, and this one is the node, and then value of node is less or equal to 10. So this is level 1, and then we have to go for 3 and 4. 3 and 4, I already have the number of node I have to find the value of node, which is sort by this one and minus this one, because I have to sort by this. So this is the number of node, and then I can just copy here. Okay, now I can sum if another one with level 4 and 3. So this one will be, where is it? Level 3 here, right? So this be number, and the value is this one. Then I don't need this. Close. Good. And then for project 2, there are 1,841 ways to get to the same one. This one, only method I know is brute force, so just go with that. Project 2 is this part. Okay. Project 2 this part, and then we just go almost the same way here with that. With what? With Percom. So just go with this. I still can go with all this. But now I want the X without anything. So this will be the summary of all the way down. So let's go with this. And with this, we can find how many methods on this one with group by. So group by X rows, and then sort -1. This one take quite long because this is have many rows, and then group by also take extra time. So here is 181. So this will be okay. There are another way to do this one. Not another way, faster way. So let's time this one up. Okay. This one I just go with 1 here to save space. See, it's take quite long time to calculate. And then if I timing this one, see how much it goes. So I just go with add here. 6.8 seconds here. Another way is I go with frequency, which also can count this. So the way is like I go unique first. Okay, unique. And then if I do the frequency on this, and then stack this. Oh, hi Sean. We'll watch the beginning of the stream later. Have you already talked about? Not yet. I'll go. So this is like count how many number, but this one only used with number. And then if I sort by second column, -1, it will go. Oh, wait. Okay. It will go almost the same, but faster. So let me combine all this together. So this one will be X. Okay, unique. I already used one. So U will be unique X. This is U. This is also U. This. Oh no. This is X. This is U. Okay. Take time, but still faster than. So let's time this one up. Okay. Timing. Oh, wait. This copy. So frequency is faster, but it's only count number. It cannot count text. So group by is more have more function to do, but this is faster. Okay, so now I want to go with Hungarian step by step here. So this is the website that I learned. The Hungarian algorithm is like we have step to do this one. Subtract row minimum. This one is can do by go the grid minus by call and min, or by row and min. So this two step is easy. Then now step 3 is we have to cover 0 with minimum number of line, and this one is this is the most challenging stuff here, because there are so many ways to cover, but I found one that work on most of the case that I try. And after we cover that line, the line that not cover, we will find the minimum, which is he called k in this one, and then we subtract k from uncover element, and then we will add the k on element that cover twice. So let's see some basic sample. So this line, okay, so we create these two lines which bool here, and then the one that not cover, which is here 13, 14, 8, 6, 64 here. The minimum is 6, so we divide we minus number 6 from that uncover from here, and then the one that cover twice, which is 12 and 90 here, we will add 6 back to this one. This means I have to generate 3 scenarios here. The one that I have to deduct, the one that leave alone, and then the one that cover twice, which is we will add that one back. And we will redo all this step until we need to select 4 lines on this case. So after we select 4 lines, we will do the optimal assignment, which is just assign 0 on each row or each column once. Okay, I have done in this. So this also sharing in the description. Okay, go with 7 by 10 first. Okay, so this one. So here the first step is like we have to go the matrix square. So we have to expand and add 0 according to that one. And then we subtract this, which is easy. And then now the step that cover 0, which is quite challenging one. And then after we do this, we add 0, and then we do until we can cover the line with 10. So just go on. So this one have done like add how many? 1 0 2 0 3 0 4 5 times, 6 times until we can get all of this. This means the step is unknown, so I use recursion on this step, and then the optimum is just on the last one. Okay, let's start with this. So so the first one, just make matrix square. So just like expand on the maximum number of row or column, and then subtract here. We just go the grid minus by row of min, and then the grid minus by call of min. And then I combine these two steps here. I reduce, transport. So I transport, so I can go just like by row twice here, and then I go this one twice. So this is almost the same. Next is the hardest one. The method I used here is I get the row with single 0 and draw line through the column. This one have, because we add 0 here, so there are no single 0 here. So I think I'll just step back to this one. Okay. This one. Okay. So we have single 0 here, which is I count with this formula. count how many zero of n and then sum. And then with this one, so we have 1 0 and then we cross that one out to find which column on that one, and we draw the line to the column. So this is 1 0 here, so we draw the line here. This is 1 0 and then 0 is here, we draw the line here. 1 0 0 here, draw the line here. So and the formula I use is like I check if it's equal to 1, and then if this equal to 1, I will look up 0 on that row. So these are the function I use. So I check if sum of x, which is check if it's 0 equal to 1, then I look for this and then find the which column it says, and then so I got this. Next step is same but in column, so find out how many column have 1 0, and after crossing that line, so okay, so the first one I go with line. So this one have 1 0, which is here, so I draw the line to that column. 0 here, 1 0, so draw the line through this column, and on the way I get to do this one, the one that I already crossed, I change that one to text with this formula. So if it's true here, I will change this one to text. So that means the 0 with text will be not count twice. So here is the formula. If ry, then I change this one to text. And if it already text, I will put positive sign. That means it's marked that this one cover twice. Then later this number with plus, I will add the minimum. The one without covering, just minus, and then the one with the text, normal text, is just do nothing with that. So okay, this is like we cover the line, cover the column here, and then we will redo again until no more single zero. So this one, no single zero on this column, on this row, and then what? Okay, so this is no single zero, and then here no single zero on the column. After this one, so this one have to be the recursion part, because we have to redo until there is no single zero. And then after that, if there are remaining zero with more number, I will cover that line, but in this sample we don't have, so we go back to this sample. Okay, so this is almost the same, but except that we can only draw the column, draw the line to the row here, because this one we add 0. So this means this column will be multiple 0. We cannot do the line that crossing that one. So after checks many times, it still have 4 lines. So this one will do recursion until there are no more number one, no more single 0 on each row or each column. And then here is the number of 0 left here, 3, 3, 3, and then this is the number left on the column, which is 6. After we finish this step, I will this one get row with single 0. No, draw the line through the maximum number of 0. So we have 6 here, so we draw this line. Now we can count how many lines here, 1, 2, 3, 4, and then 5, 6, 7. After this step, we want to find the minimum number that not covered. So because all of this is text, I can just go with min to find this one. So this is min, which is 4. And then we deduct 4 from the uncovered part, which is this. And then the one with positive sign, we will add 4 back. So we go with this. We add 4 back here, add 4 back here. that cover twice, the one inside just go negative, and we change all back to number, and we do that step with cover again. Do it over and over until we have 10 line. So it means the first recursion part is here. So this is the one that I count. Okay. So here is the C is I check if the grid is 0. So this one, and then RY is check which line have the single 0, and then show the column on that one. And then this function text to plus is like go with change number to text, and then change text to plus if it cover twice. So this one is go with line, go with row, and then go with column here. And so this is the RY and CY is the count of how many lines that I cross. And then if there are still a line to cross here, I will keep continue with this. So this part is just like cross the line, and then the L here is I count how many lines that I cross on each step. So I add L, which is start with 0, add how many row I cross, add how many column I cross, and then keep adding it until I can find nothing. And then this is the function to cross the maximum row on that one. So this part is like count how many row, how many 0 on that column, and then crossing the line on that column with the same symbol again. So we will have all this, and then we will add additional 0 with this function. Chong, I love you often define small lambda inside. Yep, T, P, and everything. Thank you. Okay. So where did I go? Okay, so this is the step that crossing the line, and then after crossing all the line here, I add text to 0, and then number to text, and then text with plus sign, and then I add 0 back, create additional 0 with this function, which is here. Oh, I have done that. Is like, okay, I do somewhere here. Oh, okay, I do it here. So okay, this is just sample. So with this grid, okay, so I'll check if what I did done at 0. Okay, so the first part is less than 0, so let gx is this one, gx is this one, minimum, which is k, we min of gx k. Oh, this one already cover. Wait, have to be done before this. Okay. So this is 4. Then the checking is gx is less than text. This is true, false. So the true will be number. This one I have to deduct back, so I go with negative sign here. And the one with positive number, I want to add 1 or add 4 back. So I have to check if this is less. What did I use? less than 0, or less than text and less than 0. Oh, okay. So if this one, if I check for less than 0, this will include text and number, but not include this part. So this one remain -1. And then I will have to add back the one that is number with 2. So 2 multiplied by gx less than text. So this one will give me the coefficient to do the plus. So this one, and this part will be multiplied by k, and then plus back the gx. So this is wrong side. Have to be another side. Okay, so gx have to be plus here. Okay, so this is my negative part, positive part, and then I multiply this with k and then plus gx back. So this is the function of add 0, which is here, add 0. Okay, so this is the add 0 part. Okay, now that we add 0, we have to do the same. Cross the line, cross the column, cross the line, cross the column, and redo everything. And I do this part with another set of recursion here till here. Yeah. So this is the part where we cross the line with single 0. And then after that, if it falls, I'm continue with this. And then this is cross the multiple 0 at once. The multiple 0 at once. And before that, I have another recursion on this one. So y is number that I cross on multiple line here, and I sum with L to check if it equal to 10 yet. So if it not, then I add 0 back here and reset the L to 0 and go back to the first loop here. But if it good, then I'll just exit the loop by add 0 onto this. So this is like exit the loop. So this is like another nest recursion inside here. So two main recursion. First recursion, when no more single 0, and then add line on maximum 0, and then another recursion is here where we add 0 and then redo on the first part. Keep redoing until all this. So we now, this one finally we will have 10 line. So after recursion, so we have 10 line here, and when we have 10 line, we can assign 0 on that part, which I use. Actually, I do something more to cover the duplicate, but I think this part should be cut. So when we have all this, I change all to text. Go with this. Go to text, and then from this by row. Okay. Let G X. Okay, this is all here. C will be N O equal to 0 with text, and then by row N sum. Oh, C sum. Oh, this is O, not 0. Oh, okay. So we can see that number 1 here, we can cross the line, cross the 0 here. So we cross, we can mark the 1. So after we cross, okay, 1, 1, 1. The row with 1, 0, we can mark that one. So this is like 91 here. uh 0. Okay, here, we can mark that, and we can cross out other line and column. So if we select this one, we can cross out other like this. We select this, we cross out other this, and this just cross out. So this is work almost the same as the first function, except that I cross the line instead of, no, I change this one to number and then change other to 0. So go with this, and then the remaining is the text here. Now with this one, just continue with easy sample here. So this is 1 0, so I can cross this one out and also cross this one out. So this, and then this one will become number 1 later, I guess. Okay, here, right? Cross this, cross this. Confused. Oh, here. So this one is this one. Then the rest is like it actually outside of the scope, because this one we add 0. So at the end, just go with this. And now I did something more. Yeah, I did something more yesterday, but not that important. So after we can select 1 0 on each row and each column, and then that number will become the minimum assignment on this one. So just around this. Okay. And then I testing it on a lot of sample. I just cover later that I can create the random cost here with any number of grid here. So I test with this one. Like so far it still work good. I still can match all the number. So just like this one, 169 here. I can go with Hungarian or this, and if I sum all this, I still get 169, and then I test a lot of this one, and I think this one should be good to go. So okay, so that's about it. And the thing that I did some more as, like, if there are some duplicate, I want to select like one. So okay, let's try with small sample. So okay, sequence of 3, no, ran array of 4 and 4, 1 to 10, 1 to 10, 1. I go with this. Good. Ah, it's not good enough. Okay, wait. 3 here. I think this one still recalculate. So this one is recalculate. Just close this one. Set. Okay, I think the number is too much. Go with 8. No. Okay. 6. Now, okay. So this is like I do the extra stuff to manage with the same number here. Copy this one, paste format. Okay. Let's go with this. Oh, So like this, we can, on this 2 row here, we can select 6 or 7 or and 7 to 6 here. So I make another function to like do the optional with question mark here. This means there are some more methods, and that is cross taking some more calculation with I put 1 if it one number available, and then I put 2 if there are more than one number available, and then take add question mark after that. So it go with that. This means if these are all same number, it will select like this, and then the rest is optional. If this is 7, then we will not select any 7 on this one. So this is like, and then I select once, that means I still can sum all this with that optional 24. So if I go 8 here, now 2 option left, still 24. Okay, so I think that should be about it. The hard part is like next recursion inside and inside, but it have to be done this way because otherwise I'm not sure how to do without this one. Important thing is this L, because I have to keep track of how many lines that I cross, which this one is like this one is the line, and another one is and here. So this keep track of the line to make conditional stop when line is less than n. Okay, I think that should be about it. Yeah. Okay. So oh yeah, I think that should be all. So thank you, Harry, and thank Chong for create this amazing case here. And this case make me create more like more lambda on this one. Do you still have some time? Yes. And then there are a lot of projects that I can work with this one, like let's just go back to Bing. Bring this one. Is it live? Oh, do you mind explaining the way to get least amount of node? Since I assume greedy. Okay. I think I have to open another sheet. I think there are some way to do it mathematically, but I don't know how to do that one yet. So the way I did here is brute force. I think this one is a sample. Okay, so like this, if we go greedy from the first one, we go, I think I'll just grab the formula from this. Okay, so this is the normal one. Start from top to bottom. So this is the node. This is this. So like this one, we select 85 first, and then the remainder will be 66 we cannot select any. Then this one, okay. But actually the best way is we can select this one, multiply by 2, we got this. So the way I did here is okay, just start another sheet. Okay, put this one away to go. Okay, let T is target here, and then B is okay. Just go with 3. Go with 1 first. B. I think what I did, reduce. Oh, this one I combine all the text. Okay, got it. So I go reduce. Start with T and B, and then want to count how many available method to go with 85. So I go T minus V, no, A minus reduce. Okay, wait, lambda A V. This is N, wait, N V, wait, okay, this is N, and this is bad naming. Reduce lambda. Oh, wait. Okay, wait. I think I follow the naming here. Okay, A L. Wait. L A L. This one is later. Drop reduce. Oh, okay. So this is the part I do. Wait. What? N. Nest reduce. Nest reduce. Wow. Wait. If this, then go with this. Else go with drop. Okay, I think I'll just go with this. From first one. And this part later. AL. This part with true false. False. Okay. So this part, first I go text split. Text split. I go this one, drop first one. Wait. Oh, hi Dim. Yeah, there are the logic on that one, but I don't know yet. So this is the way with brute force. Okay, in general here, I divide this one with this, and then the possible number to do this one is 0 and 1. 1, 3, 2 here, and then I record all the number left from this one. So this minus this multiplied by 85. So this is the remainder coin from the first step. So I record this one, and then I note it that I use ones for 85. And when I go further, each of the row I will operate each row separately. So the first one I will deal with 66, and then the first row I get this 0, 1, 2. So 3, 6, and then this This divide by 66, I have 2, so I go with 0, 1, and 2. So this is 3 line here. And if I use 0, it still remain at 132. If I use 1, it's 66 and 66. And then if I use 2, this one go with 1. 47, I cannot use the 66 because it's less than. So it's just stop with that. Next is I go with 3. So again, 132. There are divide by this. Okay, there are 4 ways to generate this one. Include 0, so this is 5. 5 here. 27. So this one is used 1 of 27, 2 of 27, and 3 and 4. And this one go on until the last turn that I don't have to recalculate. But if I do the calculation, it will go like 111, but I don't take the calculation on the last one. The last one, I just go with the amount that match on this one, which is, so this is the part that I do before the last number. And then if it equal to min, I just get the number with exact number on that one. So this is the generation of everything. But this way, when we got to a big number, like okay, this is just multiplied by 10 here. I have 3000 way already. If I go like more, it will generate too many, and then it will crash Excel at some point. So this one is only usable for small number of stuff, but there will be, I think Dim and Harry know the method, but still, I don't know that yet, but I will study it if I have time for do that later. So this is one way that I go with record everything in text, and then another way is almost the same, but I record in grid here, which used by row, B row here somewhere. So this one is just go like get coin, almost the same, except that so this is like record in what? In row. Oh, then the first row is the sum. Yeah. If I go this by 2, yeah, it's generate almost the same as this one. If I go with 3, so this is just like generation of record the number of coin on each of this one, or like this. But again, this is brutal force, so it cannot go large number. Okay, let's read the comment. Yeah, Dim is working on the coin problem. Previous node. Say might be some complicated complex number infinity series evaluation. Yeah. Your second video and last question, right? So right there, not easy to follow for me. Would be a bit like integer complexity, where the part, I don't know. There are like Chinese remainder thing that I not quite understand it, but it go with some GCD or I don't know, GCD, no, LCM. I'm not sure, but like it can calculate, I don't know, much bigger number. You need to set some limit. You will never use one more smallest one. The problem, yeah, So, this is just the way I do right now. But that one. Oh, Chongse dim use LCM. Yeah, CM, but like not that easy because like this is like only one way to generate this one, which is this number. Okay, let's try with this. So this one multiplied by this and sum. So this is like one way from 3,000 way to get this one to have the exact number on this. No idea how to go with this. I go with no. The way I thought is I still have to this one by sequence of this. No, minus this multiplied by number of text here, and then if I go mod on this part on this again, that's one still required. Okay, to roll. Oh, this again another brutal force in different angle. So mod all this with this again. And then we get 0 at some point, but sometime, okay, something to do with that. Not sure why, how yet. But yeah, I think that should be all. So I think I just gonna end it here. Yeah. So yeah. Oh, another comment from Harry. Smallest way to get min of smallest way. Wow, that's 3. 2999. That's one. Seem like oh, I did mention about dynamic programming where we go from smaller and expanding. I don't understand dynamic programming yet. So just like we try on smaller problem, and then if it 133 here, we just add one more coin from this. Right. Some kind of that stuff, but this means I have to record all the value along the way. Like 1, 2, 3. Yeah, I think I have to learn how to do that. Okay, let's go a little bit on that. Okay, try go smaller. With 1. Okay, let's take this one. Huh? No, this one. This one. This is this. Coin is this. So 1 is like this. 2, 3, sequence of 100. Like, okay, no, good. So 27 will go this. Oh, I only take the first row. Okay. Oh, and here, take first row. This is the best way for 27. 29 will be just this plus 2 because this is number 2 here. If I go plus 1, it will be like this. At some point. Do I refer previous one from here? Sequence of red. Start from this. Oh, now it's have to change. With 52, this one will be 2. It's 3 is increasing. It's use. And until some point where it's 66, it will have to add 1. Don't know yet. This is the step where we move on with the next larger. And oh, so if I mod this from this 0, then this remainder, I just take the smaller part here. The result is like for 67, it's just this part. Yeah, mod will be doing a big part here. Nice, nice. But I will try to figure out on this one later. Yeah. Try something. If I mod this with this, this part gets 0. Or if it 1, if it 1, then 1 is 2, then it's 2. Interesting. I don't, yeah, see some possible, but I don't know yet. Dynamic programming something. not really understand it, but I think that I have to record the value of previous value along the way and then recall previous value to use with the next one. Yeah, okay. I got the idea, have to understand and apply to Excel. So thank you very much, Harry, Lim, and Chong for asking the question. Yeah, I think I'll just have to end it now. So thanks for joining. See you again later. Bye. Yeah, I'm gonna leave too, Sim. Bye.